Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 3474, lexicographically smallest generated string, with an optimal greedy approach. Before diving into the solution, let's briefly understand the problem. We are given two strings, string 1 consisting of t and f, and string 2. We need to construct a lexicographically smallest string such that if string 1 at index I is t, the substring starting at I exactly matches string 2. If it is f, it must not match. If no valid string exists, we return an empty string. Let's explore the brilliant logic behind this pure greedy approach. First, we process all t characters in string 1, and lock in the required characters. If there is a conflict, we return an empty string. Next, in the second pass, we greedily fill the remaining empty spaces with the character it to ensure the lexicographically smallest result. The genius part is that if filling a accidentally completes a forbidden F match, we only need to flip it to break the match. It's that simple. Looking at the C++ implementation, we start with the first for loop. This loop iterates through string 1 to fulfill all the required t characters. If we detect a conflict where a position requires two different characters, we instantly return an empty string. This ensures our required substrings are perfectly placed. Then, the second for loop iterates again to handle the remaining slots. If the position is covered by a t, we skip it. If the current string already violates an f condition, we return an empty string. Whenever we encounter an empty slot, we default to placing in it to keep the string lexicographically smallest. Now, inside that same loop, we perform a quick look around to verify if this inadvertently creates an exact match for any f conditions. If it does, and there are no other empty spaces left in that window to fix it later, we just change the A to a B. This flip is guaranteed to break the match and remains optimal. Finally, let's analyze the complexity. The time complexity is O of n plus m times m squared. The outer loop runs n plus m times, and the inner k loop does m squared work due to m iterations in m for substring matching. The space complexity is O of n plus m, which is required for storing the answer string. Thank you for watching.